Welcome every one of you to Growing the PHP Core one test at a time with me, Florian. My name is Florian, that's me. I'm a software developer at Datadog, where I'm building a PHP profiler with an awesome team. I'm contributing to open source software. I'm a maintainer of a small React PHP library. And when I'm contributing to open source, it's usually stuff that I use or used in my day-to-day life. So that's, for example, GraphQLite, which is an amazing GraphQL API library for PHP, and PHP Unit, as well as the PHP core itself. And I'm doing so, although I'm married with 5 kids. That being said, if you do not have 5 kids at home, you have no excuse anymore. Besides you. Okay, why I'm here today. So, I got introduced to PHP in the year 2000, and I built my entire professional career on this fact. I could say that I did a lot of PHP, and I also did other languages in exchange for money. But I think it's fair to say that 90% of the time that I was coding, I was paid to solve problems using PHP. Or I was paid to solve problems, and I did so using PHP. So that means that in my entire career of 23 years now of PHP development, all the friends that I made on the way, all the money that I made, anything that I learned on that time is based on the fact that people back then built PHP, that people today build PHP, and hopefully people in the future will still work on PHP. So sooner or later, I thought that it might be a good idea to give something back to the community. And in the year 2017, I stumbled onto the PHP Test Fest. The 2017 edition was the last edition so far. And the Test Fest was organized by Ben Ramsey and Sammy Powers. And the main idea was to bring people into writing tests for the PHP core. And I thought that this could be like something that helped me to contribute to PHP itself. And but I still was a bit nervous, like, how do you write tests for PHP? But there were a lot of documentation and stuff about this, and I realized relatively quick that writing tests for PHP means you don't need to write C code, you don't need to write an RFC, you don't need to interact with the mailing list, like all those things where you might be afraid of. You don't need to do this, you write PHP code to test PHP. So I started doing, and I want to tell you and show you how to do this. So first of all, if you want to write tests for PHP, we should execute the PHP test suite. You can do so by cloning the PHP source code from GitHub. Then you go into the directory, you run buildconf, you run configure, and then you run make. The .j just make sure that you use all the CPU cores that you have, so it's compiling multiple files at once. And after that, you have your PHP up and running. I prepared this one already for us. It takes a while, so I cannot compile it live on stage. But I compiled it this morning. And here we have it. This is PHP 8.4 already. The PHP 8.3 branch got branched away 3 weeks ago. So the master branch is already labeled PHP 8.4. So if you cannot wait for PHP 8.3, this is how you run PHP 8.4 in production. And you can see when it was built at around about 11 o'clock this morning. So this is relatively fresh from the master branch. Okay, when we have PHP up and running, the next thing is that we need to run the tests. There is a test runner that gets shipped with PHP. And basically, you can start it just using the makefile. The older version of the PHP test runners couldn't run tests in parallel with the newer version since PHP 8.0. You can run in parallel using the test PHP args and just also give the .-j argument. And then you give it the number of parallel processes it should start. So let's do this. We have make test PHP args minus j. Let's just call it 10. And then we add test. And now the tests run through. This is a bit fast. It should be fast. Down here, you can see it's 10 of 10 concurrent test runners. And you see the number of tests that are currently running. You see a lot of green. Hopefully there's more green than red. And it will slow down in a few seconds when the first test runners are finished with their tests, and it gets slower a bit. Then there is some tests that will definitely fail because they are relying on internet connection. I don't have the Wi-Fi set up on this laptop, so they're not doing anything. And in the end, it asks you if there were failed tests, if you want to send a test report. We do not want to do this now. And the interesting thing we see here is the test result summary. So the test result summary shows you the number of extensions that have been skipped. That's basically because I did not compile them with this version of PHP. And then you see the number of extensions tested. That's 27 extensions tested, 46 skipped. And you also get the same breakdown for the number of tests. So we have 18,577 tests in the test suite overall. 30,102 tests were executed, of which we have 4 that failed, 7 that were expected to fail, and overall we have 99.9% success rate, which is great. And the best thing about this, it took only 34 seconds to run the entire test suite. Now, the next thing you get for the expected fails, for the warnings, we have no warnings. For the fails and for the expected failures, you get a result summary again. So there is the expected fail test summary. This is these tests all. Sometimes there is a reason why a test is expected to fail. So you want to run them, but you know it's failing for a reason, and that reason might be that in this one test, the open base there cannot delete symlink to profited files. See also, and then there is a link to bug reports. So maybe there was an upstream change or the other way around. So there was a bug discovered in PHP, and you did a contribution to the upstream to fix that bug. But you already have the test here to prove or to show how it should be. And then you can set it to fail. But you also want the test runner to execute it. Then there is failures. There's the getHostByName function. Doesn't work. It's probably because I don't have an internet connection. The same with the getMX record function. Then there's a DNS get record failure on FreeBSD. This is not FreeBSD, so it should probably not execute the test, but it's probably also failing because there's no internet connection. And the last one failing is the XML writer open URI. That has probably nothing to do with a failing internet connection. So someone should have a look at that. And yeah, that's basically the summary that you get from running the tests. Now, the next thing to look at is we now know how to compile PHP and how to run the test. The question is, how does a test actually look like? Like, what has this thing executed now? And this is the basic test, how it should look like. So what you see is it's just an ASCII file with sections. The first section being the test section, which just holds the name. It's something to print out when the test runner runs, so you see what test has failed or what test is being executed. The next thing is, in this case, an extension section. Sometimes you have the case that your test that you're writing is depending on an extension being around. So, for example, later we're going to see the setlib extension. The setlib extension is not compiled by default. So if there is a PHP version that you run the test on and it doesn't have this extension, then it does not execute this test because it makes no sense. It will fail anyway. Then there is a skip if section. That's just PHP code. This one. That's just PHP code that the test runner will execute. And it will react on the output of that. If the output starts with skip, it will skip the test. The thing you see here, the check on function exists string line makes no sense. If this function does not exist and the core extension is loaded, we have a problem. But just to demonstrate this. The other thing is the skip if section could start the output with x fail. And then you would also, then the test runner would execute the test, but it would expect it to fail. Then we have the file section. The file section is the actual test, the thing that we want to test. And in most cases, what you do is you just var dump out something that a function call returns you. So in this case, we call stringlang with hello world, we var dump this out, and we expect, that's the expect section, it to be int 12. And what the test runner does, it executes the PHP snippet in the file section and matches whatever it is against the expect section. And when it matches absolutely correct, then the test is green, otherwise it failed. There's other sections as well. So if you, for example, let's say the 12 that we have here is dynamic, you don't know while writing the test, you could use an expectf section in which you could use the substitution tags that you know from printf. So you could write int brackets %d, closing brackets, and then it would match any number that's there. It would render this test also useless, but it would technically work. And then last but not least, there is a clean section, which you could use to clean up after yourself. One thing you need to keep in mind, even though this is one file that you create, those 3 sections that we see here are being called in isolation. So the test runner will actually split the file up into separate files and then call the skipif file with a PHP process. And after it decides if it runs the test, if it runs the test, it calls a file with whatever you have in the file section here in a new PHP process. And afterwards, it will call the clean file if you have a clean section. That means that you cannot pass variables around from one section to the other. Even though they're running in that order, you cannot pass any variable around. It's a new process. Those variables just don't exist anymore. And well, we know now how those tests look like. The question is, what do I test? You can assume that there is a lot of tests already there. But the question is, like, how do you find something to test? And there was gcaf.php.net, which sadly is not there anymore. But you can find at the end a link to my blog where you find a blog post about how to create a code coverage report. That's a little bit more to do, and it's too much for this talk. But in the end, if you create that code coverage report using gcaf, you get something like this. This is what I found in PHP 7.1 in the setlib extension. This was all red. There was no coverage. And this is a PHP function, setlib get coding type. Then there is a if send pass parameters none, which checks on failure. Basically, what this does when you call the setlib get coding type function and you give it a parameter, it doesn't expect anyone, then it just returns nothing. And then there is a switch statement. Without reading too many of the C code, it's a switch statement on a compression coding variable. And in the one case, it returns the string gzip. And in the other case, if that compression coding variable matches PHP setlib encoding deflate, it returns deflate. Or if it's nothing from those two, then it returns false. So that looks easy. And at least I thought it looked easy. So I was starting to look into how do I write a test for this thing. And there is multiple options that you have. One would be to look more into the source code, what's going on. I mean, we have here some stuff going on. The other thing is go to the documentation for the setlib get coding type. So just go to php.net/setlib get coding type. And you would see what it does. Basically, what's going on here is that a browser sends you an HTTP request, and it can send you an accept encoding header. So the accept encoding header can be, the content can be gzip, deflate. Newer browsers also send BR for broadly, or other compression algorithms, whatever. And PHP has a mode where it does magic output compression for you. So whenever it detects that a client sent an HTTP accept encoding header with gzip or deflate, and there is an INI setting turned on that PHP should do magic output compression, it does for you. So this is pretty easy, I thought. Next thing we got to do is we got to write a test. We now know that we can influence the behavior of that function, or we should be able to influence the behavior of that function using the HTTP accept encoding header. And we can test for the absence of the HTTP accept encoding header. Like if there is no accept encoding header, it should return false. If there is one set to gzip or deflate, it should return either. Or if it's probably BR or something else, it should return false because it doesn't support the compression algorithm. So that's the test we're going to write, and we're going to start writing a test for the gzip case. So there's something that I prepared already. It's this test. Yes, is the test for setlib get coding type function with gzip encoding. That's what we want to test. We are depending on the setlib extension. I have to express this explicitly because the setlib extension, as mentioned already, is not compiled by default. And then we need a file section where we write the test. And then we have the expect section. In the file section, what we do is, first of all, we know that we need an HTTP accept encoding header. It should be gzip. So the easiest way to influence this one is through the $_server superglobal. That's where we can also read it from. So we can write $_server HTTP accept encoding, set that to gzip, and now we faked a HTTP request or a client sending an HTTP request with an accept encoding being gzip. Next thing we're gonna do is to set the INI setting to off the setlib output compression. This disables magic output compression for PHP. And the next thing is we call var dump and just dump out whatever setlib coding type returns. I would say that it should return false because except the HTTP accept encoding header is gzip, but the output compression is turned off, so PHP shouldn't do anything. And then when we switch output compression to on again and call var dump again, it should return gzip because now the HTTP accept encoding is gzip, output compression is turned on, PHP should do output compression, and setlib coding type should return gzip. So let's run this test. If you want to run a single test, you can just call make test and give it the tests argument. And give it either a directory or a direct file, and then it will execute just this single test. And oh, you see it's failing. So it executed the setlib coding type with gzip encoding. That's also the right directory. That's our file, but it failed. The good thing is it failed fast, 0 seconds. That's nice. Now the problem is it failed. So I mentioned earlier that the PHP test runner will split the PHP file that you have in different files. And if the test breaks, you keep all the pieces laying around. And that's, for example, let's have a look. That's this file. There is a diff file laying around. There's a diff file laying around. There's an expect file laying around. The log, the out, the PHP file, the original PHP, and an sh script, which is the how to execute the PHP file. And in this case, what could help us is the log. If we look into that, we get the expected output. That's what we already saw. We expected to output false and gzip. The actual output is false for the first one. That's good. So we have 50% covered. And then we get a warning, which we did not expect. And that's interesting because that says headers already sent in some file and then Boolean false. So headers already sent. Let's have a look at the test again. That's this line where it says that the headers are already sent. So what's going on here is PHP got an HTTP accept encoding with gzip. The output conversion is turned off, and then with this var dump, it started doing output. What PHP will also do magically for us is that it will start sending the HTTP response headers. And the HTTP response headers will, in this case, indicate to the client that there is no output compression happening. Now we cannot just turn it on again and send part of the response compressed and another part non-compressed. The client has no idea what's happening. So we cannot change this, which is not too big of a problem. We can just store this in some variables. Let's do this as well, even though it's not necessary. And then just the var dump out. And this should not do any output. The setlib coding type is called. We store the value in a variable. Then we turn output compression on. We store it again in a variable and just output it. This should not send any headers, at least before we not sending any headers before we change the setlib output compression. So let's run the tests again and see it fail again. But we know we can already look into the log file, and this is interesting. Like progress, we did get rid of the warning, but it's still false. Okay, so it's time to dig a bit deeper. I showed you the implementation on the slides, but let's have a look into the actual source code. This is the PHP version 8.4. The only thing that changes is exactly in this line. Changed to PHP 7.1, like we had on the slides. In PHP 7.1, I think to 7.4 maybe, it would just return. Now it returns throws. So basically, if you call it with an argument, it throws an error that you could catch. So, okay, it switches on the compression coding variable. Nothing big changed, but now the thing is, okay, we gotta look like somewhere in this file, someone needs to write to the compression coding variable. So we need to find this one. So just let's skip through and find the compression coding variable. And here we have something. So this PHP setlib output encoding function writes to the compression coding variable. It does some checks. So if there is no compression coding, also this is interesting. This is HTTP globals, trackvar server, whatever that is. It looks a bit like it could be the $_server superglobal. It checks if this is an array. Another check on send string auto global, whatever that is. This is interesting here. This ensures me a bit that this is the right variable that we're looking for, the $_server, because this is an access to the trackvar server, and it's a send hash string find. Arrays in PHP are hash maps. So this is searching in a hash map for something that's HTTP accept encoding. So this actually, it looks like a bit, it bakes our case. This should be the right thing, the right way to do it. It doesn't convert to string, whatever that does, but then it checks if whatever we had in $_server HTTP accept encoding is gzip, and then it writes the PHP setlib encoding gzip to the compression coding variable. Otherwise, it checks for deflate. So this all looks like it actually bakes our case. It doesn't help really. So the next thing that you can do, the next thing that I did, is you can go to phpc.chat, where you find a link probably to Room 11 on Stack Overflow, where you find a lot of the PHP core developers. And you can ask them the question, what's going on here? Why can't it just work? And when you show them this test, they told me then that there's one thing that I knew, but I didn't know 100%. PHP does copy on write, and it does the same thing here with these auto globals. When you write to one of the other generated super globals in PHP, like $_server, PHP creates a copy for you to work on in user space, and PHP core itself holds the original hash map for it internally to work on. So even though we changed the HTTP accept encoding to gzip here, it is gzip from now on in user space, but it's not gzip in PHP core space. So we can't do it like this. Now I mentioned there's more sections, and there's one section that comes to the rescue here. There is a --env section, which allows us to inject environment variables into the PHP process before it gets started. And those environment variables also end up in the $_server superglobal, so we could try and inject it like this. And then let's run the test again and see what we got from it. And it fails again. Okay, let's have a look. Oh, okay. This is progress. And this is something totally crazy. I have no idea what this is. But it's definitely not what we expected. But let's have a look again at the test. So we inject, or we fake an HTTP request with an accept encoding of gzip. We turn it off, we call setlib coding type, we turn it on, we call setlib coding type again, and then we var dump. Anyone want to take a lucky guess what's going on? Yeah. Yes. PHP is doing what we expect it to do. So it's not PHP fault. It's a problem sitting between chair and computer. So what we could do is, for the sake of simplicity, we could just turn it off again and not have PHP doing any output compression. And run the test again, and fingers crossed, it's working. Okay. So this is the version as you might find it in the PHP repository. I made a pull request for this version, for gzip, for deflate, for being empty, for being, I think, BR. And that got merged in PHP 7.3 in the code coverage report. That looks like this. We have 8 calls into the function. That's because there's 4 tests. They called it twice. So we have 8 calls into the function. We have the calls on the return string gzip on deflate. We also have the return false 6 times. And yeah, that's basically how the code coverage report looks like. So what did I learn when I'm writing those tests? First of all, the usual thing. What looks simple might be complex. There is this quote that I found once, which pretty much fits here. That's we don't do it because it's easy. We do it because we thought it would be easy. That's why I did it. Superglobals are copy on write. I knew about the copy and write thing, but not that superglobals are also changing. But it makes totally sense for them to be immutable to the PHP core itself. Because imagine an HTTP client sending you an HTTP accepting coding bean gzip. You change that to deflate for reasons, and you send a deflate response, and they have no idea what's going on. Yeah. Then there are modify handlers for INI settings. The first test that failed because we already sent out stuff. We are not allowed to change the INI setting anymore. And this was actually new for me. I'm not doing that much INI set calls, but usually when I did, I just fire and forget, because why not? But actually, INI set will give you back an error in case it didn't work out. So you should probably check on these things. Sometimes you're not allowed to change INI settings. And well, you could also ask what's in for you. If you would start writing tests for PHP, first of all, PHP will be more stable. It will be more reliable. Things that you write tests for, things that have code coverage, they will not just change and go broke in the future, because there is a test failing and then people can fix that or can fix the code. You gain a deeper understanding of how PHP works internally. You can find out how things are actually working, like that arrays in PHP are hash maps and when you should use them and when not. And the other thing is learning the PHP file format. It looks not so complicated, but the thing is, you might think it's just for PHP itself, but it's also PHP unit has a test runner that executes PHP files. So in case you have CLI applications that run a test with these things, you could use PHP unit to test the output. That's the one thing. The other thing is that PHP unit itself also has a big part of its test suite in PHP files to test the output of what PHP unit does. So that's basically how I became also a contributor of PHP unit, by running the test suite, checking the code coverage report, seeing stuff that's not covered, writing a test for it, refactoring it, making a release, rolling it back, writing more tests, things like this. And the other thing is, one final thing that's in for you, what you gain when you start writing tests for PHP, is that you can call yourself a PHP contributor. That's all, folks. Thank you very much.